Hello, welcome everyone in today's class. Uh, let's continue with our topic trigonometric functions, and more. Let's go through the last sort of variations with the identities. I told you that there is one important variation that comes from the cos of double angle. First of all, let's discuss what is a variation and how it is being applied in few questions, and that particular identity will come in a lot of other chapters also. So let's see. Cos 2x, it is equal to 1 minus 2 sine square x, as well as 2 cos square x minus 1. If I talk about theta, let's take in terms of theta or a, 2a. So 1 minus 2 sine square a or 2 cos square a minus 1. If I use only these two and I try to generate only single sine square, so basically I can get take this here and this term here, so we'll get two sine square a is equal to 1 minus cos 2a. Okay. Similarly, I can generate 2 cos square also with this one. If I take this one to the other side, it will become 2 cos square a is equal to 1 plus cos 2a. Now this is the variation I was talking about. Basically how we deals with, there are a lot of form to deal with, but I personally prefer this one only because we can generate variations through it directly. Directly learn 1 minus cos of double angle is 2 sine square of the half angle, and 1 plus cos of double angle is 2 cos square a. Now the benefit of this is you can actually use this to remove square. Suppose any question there is sine square cos square present and addition subtraction is going on, you cannot apply sine square 2 theta plus cos square theta something, but what we can do is we can generate this 1 minus cos 1 plus cos using these formulas, basically using in the reverse direction. Okay. Also, how this can be further manipulated is if I write the same identity in instead of 2a, I write this in terms of a, means 1 minus cos a, that will be 2 sine square a by 2. 1 plus cos a, I can write this as 2 cos square a by 2. So this is also another variation in which, if suppose the question asks for half angle of sine and cos, we'll use this. Okay. So these are the main variations that I was talking about. Let's see the uses of it. Okay, so let's take the first example, how we can apply it. Look at the question itself. The question will give you the hint. Tan x, he has given you the value. He has mentioned the quadrant that x belongs to pi to 3 pi by 2. That means this is talking about third quadrant. Okay. He is asking us to find sin x by 2, cos x by 2, and if we can find these two, we can pretty much find tan x by 2 also. So the main task is to find sin x by 2, cos x by 2. How can we generate half angle of sine and cos? Of course, we cannot generate directly through tan, but if we look at the formula, this one here, we can see if I know cos of the angle, I can generate 2 sine of x by 2 and 2 cos of x by 2 also. So let's use this idea now. First of all, from tan, let's convert it into cos. If tan x is 3 by 4, so let me draw a right angle triangle. So if this is our angle x, tan is perpendicular upon base. So if tan x is 3 by 4, I'm assuming basic knowledge of grade 10th, perpendicular upon base. Okay. So Pythagoras, using Pythagoras, you can find this side will come, hypotenuse will come 5. Now directly generate cos x, because we need cos x. Cos x will be base upon hypotenuse. Base is 4, hypotenuse is 5. Okay. Now the tricky part is that since it is in third quadrant, x is in third quadrant. In third quadrant, we know after school to college, only tan is positive. Okay, after school to T is for tan. Tan is positive. In third quadrant, everything else is negative. So cos must be negative. So we'll apply a negative sign on our own. Okay. If you try to generate using standard identities, plus minus will come and you can justify it. But this is like a short way, specifically for objective, if you are doing this. So directly use this concept of grade 10th. Just form a right angle triangle, directly find perpendicular base hypotenuse, and just find cos sign using the basic p by h, b by h, and positive negative you can apply using the quadrant itself. So cos x is minus 4 by 5. Now let's use it. The identity says 1 plus cos x is 2 cos square x by 2. I know cos x, let's put the value of cos x. So if I put the value of cos x, so 1 plus minus 4 by 5 is 2 cos square x by 2. I can find cos x by 2 using this equation. So this basically this becomes 1 by 5 is equal to 2 cos square x by 2. Take 2 on the other side. So this will become 1 by 10, and take square. Because of this square root will come. So that will become cos x by 2. But whenever using square we generate square root, there is always a plus minus. The idea is x square is equal to a, then x is equal to plus minus square root of a. So because of the square, always plus minus gets generated. Now the answer can either be plus 1 by root 10 or minus 1 by root 10. Now how can we decide which one it should be? Now see, we'll decide the quadrant again, that if x was in third quadrant, I need to decide where x by 2 can lie. Let's take some more space. So x is in third quadrant. So x by 2 is in which quadrant? That's what we have to decide. Now in order to decide this, I'll give you a very simple trick. You take any angle that is in third quadrant. Let's say x is in third quadrant, it is, let's say, 200 degree. Okay. Third quadrant means more than 180 degree. So let's say 200. So x by 2 will be 100. 100 is in which quadrant? This is in third quadrant. 100 is in which quadrant? 100 is in second quadrant. So I can say x by 2 will be in the second quadrant. Okay. Now given that x by 2 is in third quadrant, that means cos x by 2 is in second quadrant. Cos is negative. After school, sine is positive. In second quadrant, cos is negative. So cos is negative, therefore I can say that cos x by 2 is minus square root of 1 by 10 or 1 by root 10 basically. I hope this clarifies a lot of things, because there is concept involved as well as there is a new variation of the formula is involved. Formula I gave you already. I told you that this is how you can go for half angles. But what about this positive negative? This can be judged based on the quadrant. X is in third quadrant. Take any value. I'm not saying that it works only for 200. Take any value which is in third quadrant, divided by half, and judge in which quadrant the x by 2 will lie. And according to that, you decide whether this should be positive or negative. Okay, second quadrant cos is negative, so this should be minus 1 by root 10, not plus. Same thing we can do with sine also. So let's solve for that. 1 minus, we need more space I think for this now. That should be sufficient. 1 minus cos x is 2 sine square x by 2. Okay, let's use this. So 1 minus 4 by 5 it is equal to 2 sine square x by 2. So that becomes 9 by 5 is equal to 2 sine square x by 2. So 9 by 10 and then square root of it plus minus. That becomes your sine x by 2. And x by 2 is in second quadrant. So let's modify this. 9 is basically 3. Square root of 9 is 3. So plus minus 3 root 10. That's your sine x by 2. Now again same thing. X by 2 is in, we have already decided it's in second quadrant. So in second quadrant it implies sine x by 2 will be positive. That gives us sine x by 2 as plus 3 by root 10. Okay. Since we know sine and cos, it's very easy now. Just divide them, you'll get tan x by 2 also. So tan x by 2 is just using this basic idea, something from your childhood, sine by cos. Sine x by 2 cos x by 2. So root 3 by 10 minus 1 by root 10, and that gives us minus 3. Of course x by 2 is in second quadrant, so tan will come negative anyway. It has. Okay. So these are the 3 answers the question was asking. How to get half angle. So remember, like any time they ask you sine x by 2, cos x by 2, tan x by 2, anything, you need cos. You don't need tan anything. If you get tan, convert it to cos and then use this property directly. 1 plus cos is 2 cos square x by 2. 1 minus cos is 2 sine square x by 2 directly. Okay, fine. All right, let's look one more variation, how this can be used to solve another complicated question, in which you will get stuck at the first step itself if you don't know this property. Okay, look at the question itself. You are given cos square x, fine. You are again given cos square x plus pi by 3. We may apply a plus b, cos a plus b, but there is a square also present. So even after opening a plus b identity, we have to still square it. Very complicated. Same thing, cos square, again x minus pi by 3. So a minus b we can apply, but again the problem is that because of the square, we have to open a whole square identity. So I hope you understand why this question is slightly complicated from the first step itself, because we cannot open it directly. Okay, if I cannot open it, we cannot even apply cos c plus cos d or anything like this, because square is present. There is no such identity on cos square a plus cos square b. Okay, so what we can do here, we can use removal of square, the heading of this class as such. The identity that I gave you was to remove the square. We can use the identity. The identity was 1 plus cos x is 2 cos square x by 2, or let's do the other one also. 1 plus cos of double angle is 2 cos square x. Now apply this in reverse direction, means if 2 cos square x is there, I can rewrite this as 1 plus cos of double angle. Okay, the idea is whatever angle is there, just double it. But first of all, 2 cos square has to be there. So there is no 2 present here. So what I'll do is I'll multiply the whole expression by 2 and divide it also by 2. Means numerator will be getting multiplied and 1 by 2 will keep outside. So if I'm multiplying by 2 and dividing by 2, so 1 by 2 I'm keeping outside. I'm multiplying remaining terms, so I get 2 cos square x plus 2 cos square x plus pi by 3 plus 2 cos square x minus pi by 3. I'm only solving LHS. Okay. All right. Okay. So far what I've done is just multiplied by 2 and divided by 2. Now look at this first expression itself. 2 cos square x. I can rewrite this as 1 plus cos of whatever angle is written, I will write double of it. That means 2x. 1 plus cos of whatever angle, x plus pi by 3, I'll write double of it. So 2 times x and 2 times of this pi by 3. So 2 pi by 3. Similarly for this also, 1 plus cos of 2x minus 2 pi by 3. The benefit is that you are getting generated 1, 1, 1 and by 2 is already there. Look at your 2 proof. Your 2 proof is saying that it should be 3 by 2. Anyways, if it's an objective question, they might ask you what is the value of it. But anyways, it is getting generated, so let's take it out. So 1 by 2 I'm keeping as it is. 1 plus 1 plus 1, I get 3. Now I have to deal with this cos 2x. Cos 2x plus 2 pi by 3. Cos 2x, 2x minus 2 pi by 3. Okay. This is also plus. All right. Now, after getting to this step, since we have removed the squares and everything, you can pretty much guess this is cos something plus cos something. This is cos c plus cos d. We can directly apply it. So 3, cos 2x, 2 cos angles. First, what we do? Add and divide by 2. So 2x plus 2 pi by 3, 2x minus 2 pi by 3. 2 pi by 3, 2 by 3 cancels. 2 plus 2, 4. 4x by 2, 2x. And then again cos c minus d by 2. So subtract them. So when you subtract them, 2x and 2x will cancel. 2 pi by 3 minus 2 pi minus of minus 2 pi by 3, you'll get 4 pi by 3, and then divide by 2, again you'll get 2 pi by 3. Okay, 2 cos c plus d by 2, cos c minus d by 2. This is what I have done. Add them, divide by 2, subtract them, divide by 2. Now 2 pi by 3 is a standard angle. Pi by 3 is a standard angle, na? I told you to remember this. Pi by 3 is 60 degree. So 60 degree into 2, this is 120 degree. So what is cos 120 degree? This is cos 180 minus 60. That means minus of cos 60 degree, which is minus 1 by 2. So 1 by 2, 3 plus cos 2x plus 2 cos 2x and into minus 1 by 2. Now 2 cancels, and look at the expression now. 3 plus cos 2x minus cos 2x. Now I think pretty much everything is done. This cancels, so effectively we are left with 3, and outside there is 1 by 2. So 3 by 2, that's your answer. But the key idea was where to begin with this identity. How do we know that we have to use this identity? Because square is present, we cannot do anything with the squares. That's why we have to remove the square. So whenever you are learning this identity, learn the heading also, removal of squares. This identity is used to remove squares on sine and cos. Okay. So beautiful question and a beautiful solution also. All right. Last one more example, simple one. This one is pretty simple as such. You can pretty much easily identify what is going to happen. And now that we have done a complicated question, the easy questions actually become simpler to identify. You can clearly say sine square, sine square. We cannot apply anything here. We may be able to apply a square minus b square, but that will not generate this at all. You can try if you want. But anyhow, if I use the idea that I can use removal of squares. So what was the idea? The idea was that 1 minus cos 2x is 2 sine square x. So first of all, 2 is not there. So how can we generate? Again, same, divided by 2. Then multiply each term by 2. We can generate this. And now let's solve it. 1 by 2, 2 sine square 6x, I can write 1 minus cos of. Remember that whenever we are generating, we are doubling the angle. So if 6x is there, then there should be 1 minus cos of 12x minus 1 minus cos of, what is double of 4? 8x. Okay. So now 1 by 2, let's open the bracket. So that becomes 1 minus cos 12x minus 1 plus cos 8x. 1 cancels. and this is nothing but again cos C minus cos T. Just apply the property of cos C minus cos T. So 2 minus 2 sine C plus T by 2. So 8 plus 12, 20, 20 by 2, 10x sine C minus T by 2. So 8 minus 12 minus 4 divided by 2 minus 2x. Okay, this 2 and this 2 cancels, and in the sign negative can come outside, so when it comes outside it will cancel this negative, so that generates your RHS sine 2x sine 10x. I've used sine of minus theta is minus sine theta. Okay. So another simple idea, that if you see squares you cannot do anything about it, just remove it. How can we remove? By using 1 minus cos 1 plus cos of double angle. Okay, so those were very standard results of 1 minus cos 1 plus cos. We'll use this again in limits and integration, so do remember them. Let's move to the next subtopic, that is trigonometric equation. So first of all, what is a trigonometric equation? So far you have seen a linear equation like 3x plus 7 equal to 0. That's your linear equation. You have seen a quadratic equation also, x square plus 4x plus 3 equal to 0. That's your quadratic equation. How about a linear, then trigonometric equation? Trigonometric equation will look like this: sine x is equal to 1 by 2. Now you'll say this is pretty easy. We know sine x is 1 by 2. That means x is 30 degree. Yeah, that is one of the solution. There is a reason we are going to study this topic separately, because as such there are infinite solutions for a trigonometric equations. So we'll talk about two types of solutions: general solution and principal solution. Okay, let me first give you the idea why this is not the only solution, because sine is also 1 by 2 when you calculate for 150 degree. But we don't give our answers in degrees, we give our answer in radians. So pi by 6 and 5 pi by 6. If you calculate for both the angles, sine x is 1 by 2, because in second quadrant sine is also positive. So right now we are considering that this, for this 30 degree angle, sine is also 1 by 2, and for another angle, that is 150 degree, sine is also 1 by 2. But we know that there is no effect of rotation. That means even if we are completing whole circle and then coming at this 30 degree, that means now this will be actually 360 degree plus 30. So for that angle, that means for 390 degree also, sine will be 1 by 2. What about two rotations then? For two rotations also this will happen. That means 360 degree into 2 plus 30 degree again will give us another solution. That means there are multiple answers present for sine x is equal to 1 by 2. So we'll have to constrain ourselves to find the principal solution and the general solution. Okay. So first of all, for any equation, trigonometric equation, there are two types of solution. One is principal solution, and there is then general solution, which covers all the infinite answers. Okay, general solution. Okay, first we'll talk about only principal solution. I'll explain the general solution later. So for the time being, what is your principal solution? All solutions between 0 to 2 pi, means we are talking about only one single rotation. Okay, so basically every time you will have two solutions for 0 to 2 pi. Those are called principal solutions. General solutions are infinite, so we'll have to give a general rule. General rule for the solution. Let's first understand how to find principal solution, because without this you cannot find your general solution. So I'll resemble this principal solution with theta. Okay. Okay, let's take one equation, very simple one. Let's say I'll start with sin x is equal to 1 by 2 only. Okay, we have to find general principal solution. So we've already covered it. Now I'll explain you how we can actually find it, but still let's try to find it anyway. We know the basic one, that is for this is 30 degree, that is pi by 6. So every time you are going to make a solution, first of all, in order to find a solution for positive or negative values of sine and cos, always make this x-axis y-axis. Okay, and let's write the general idea that we have, that x is, we know, 30 degree. First we'll calculate in degrees and then we'll convert into radians. So if you know this is a 30 degree, so just in the first quadrant make a line or make a triangle of basically 30 degree. Okay, so for this 30 degree we know sine is 1 by 2, but we know sine is positive. This is a positive quantity, so sine is positive in first as well as in second quadrant. So we will make the same basic triangle of 30 degree but in the second quadrant as well. So we'll make the same triangle but in second quadrant. This will also be basically of 30 degree, but remember the definition of theta. Theta is always calculated with positive x-axis. So this angle is 30 degree and this one will be 180 minus, this line is of 180 degree, so just remove 30 degree from it, so you'll get 150 degree. So your basic solution is 30 and 150 degree. If you convert this into radian, you'll get pi by 6 and 5 pi by 6. Okay, so the idea is to make general triangle in whichever quadrant he is asking, and then calculate angle with always positive x-axis. Now you might think this is too much, why do we even need this? The benefit is when you're dealing with negative values. Suppose you are solving this now, sin x is minus 1 by 2. I'll take the same values so you can easily relate. Okay, okay, so sin x is minus 1 by 2. We cannot directly guess the value exactly. Okay, it will take us time to identify. So what we can do is, first of all, judge the quadrant. Sine is negative in third and fourth quadrant. Okay, okay, now forget about this negative sign and focus only on this 1 by 2. Sine is 1 by 2, so sine is 1 by 2 when the angle is 30 degree. So make the quadrant okay, yeah. So okay, so let's make, the basic idea is that we have to make a triangle of 30 degree in third and fourth quadrant. So let's make a triangle. So in third quadrant it will be like this, in fourth quadrant it will be something like this. Okay, I'm approximately drawing this anyway. So like this. So the basic angle here will be 30 degree, here also acute angle will be 30 degree. But remember, how do we measure the angle? We always measure it with positive x-axis. Now calculate how much this will be. This is 180 degree line and you have to move more than 180, 180 plus 30. So they basically, this becomes 210 degree. And for this one, how much we can measure? This complete angle is 360 degree. We have to move slightly less than 360 degrees. 360 minus 30, that is give you 330 degree. This is the benefit of making that basic triangle and judging the quadrant. So x is basically 210 degree and 330 30 degree. If you convert this into radian, never give your answers in degrees. So radian, this will be pi plus pi by 6, so 7 pi by 6, and this will be 2 pi minus pi by 6, so 11 pi by 6 basically. You can convert it using multiplying by pi by 180 also. Okay, all right. That's the idea. Okay, now that we have done for sine, I'll solve for one more, and now let's do it for one. I'll do for tan also. We can do for tan. Let's solve for, let's say tan x is equal to 1. Let's take very simple one. So we know that tan x is 1 in for 1, the value 1 comes when 45 degree angle is there, basic angle that you should know. But this is in, tan is positive in first and third quadrant. So basically we have to make the basic triangles in first and third quadrant. Okay. So first quadrant is very basic. Okay. And in third quadrant also. So the basic idea is that the triangle will be of 45 degree and this triangle will be also of 45 degree. Now make the measurement using positive x-axis. So this is still 45, no issues. Okay. But if you measure this, now this will be 180 degree till here. Okay. 180 degree till here plus 45 more, so that will be 225 degree. So basically your x will be, two principal solution will be pi by 4 and this will be pi plus pi by 4, so 5 pi by 4. Okay, basically I have converted 45 degree and 225 degree. Same thing you can do with negative also. Tan x is negative. So whenever you are dealing with negative, forget about the negative. That's the key idea. Suppose you are dealing with tan x is equal to minus 1. So for that also what you can do is construct x-axis, y-axis. Make the basic triangle of 45 degree. In, now this time tan is negative in second and fourth quadrant, so second and fourth. This one I'll extend like this. Okay. So that will be of 45 degree. This will also be of 45 degree. Remember to make the basic acute angle with the x-axis only, positive or negative, never with the y-axis. And now do the measurement from positive x-axis. How much this will be? This is 180 degree minus 45, so you will get 135 degree, and this one will be this still this is 360 degree, so less than 360 degree. 360 minus 45, you'll get 315 degree. So basically your x is two values, 135 degree and 315 degree. You can convert this into radians. Okay. 3 pi by 4 and 2 pi minus pi by 4, 7 pi by 4. Okay. So far we have learned how we can find the principal solution, two solutions between 0 to 2 pi for any value of sine, cos, tan. Always convert everything into sine, cos, tan. Even if it is for cot, convert it to sine, cos, tan. And even if it is for negative value, solve it for basic positive value. Just draw the triangle according to the quadrant and measure the angle with positive x-axis. Okay. Now I'll give you the rules for general solutions. See, general solutions, they are just rules here. Okay. So for general solution, the idea is that you should be able to find, first of all, a basic principal solution. Suppose we are solving sine x and it is coming to be some sine theta. Basically theta is the what? Principal solution. So in that case, x is given by x is equal to the, how we can write general solution, n pi plus minus 1 raised to power n into theta, where theta is principal solution, n belongs to z, and theta is principal solution. The idea is to use the principal solution which is lesser in magnitude, so basically smaller value. Okay, but we can use any value as such. So this is the format you need to learn. Similarly for cos x, suppose it is coming to be some cos theta, we can find theta, na, principal solution. So in that scenario, cos x will be equal to 2n pi plus minus theta. Again, n belongs to integer. And similarly for tan x is equal to, suppose it is tan some theta, in that case x is given by n pi plus theta. Okay. So what is the idea here? Idea is that if you put value of n equal to 0, 1, 2, 3, 4, you'll get infinite solutions. The one that I was talking about in the first example, like we can do 360 degree plus 30, 360 into 2 plus 30. Everything is pretty much covered here. These rules cover everything basically. So these are the formats that you should know for general solution. Okay, even include this. Okay. Now, one is how do we use it? It's very simple to use. So I'll just solve few questions and we'll deal accordingly. Okay. So cos x suppose equal to 1 by 2. First of all, we need to find the basic theta, because without that we cannot use the format. So first of all, theta is 1 by 2, cos theta is 1 by 2. We need only one value. I'm not going to find both the values. Right now I need only one value. Cos is positive in first quadrant, 1 by 2 is for 60 degree. Okay. Sin 30 is 1 by 2, cos 60 is also 1 by 2. So 60 degree, or basically pi by 3. Now I know theta. Actually I need only one theta. I'll prove it. I'll write cos x is equal to basically cos pi by 3. And I can convert now using the format that I have been provided. It is equal to cos x is equal to 2n pi plus minus pi by 3. That's it. This is the general solution. Means what we have to do, basically we need principal value theta and put it in the format. That's it. We don't have to do anything else. We have to write this, n belongs to z, means integer. Now you put the value of n as 0, you'll get plus pi by 3 and minus pi by 3 also as a solution. You put n equal to 1, you'll get pi minus pi by 3. You put n equal 2 pi minus pi by 3. So basically your 5 pi by 3 also as a solution. You put n equal to 2, 3, 4. Basically it covers all the effect of rotation. Okay. So this is all about general solution. So general solution is not typical. All you need to do is learn the format, and you should be comfortable finding the theta first, principal solution. All right. Now let's solve one more. Now not always you'll get a very straightforward equation. Okay, like cos x is equal to 1 by 2. Sometimes you get these kinds of typical equations also. So for that, how we can solve it? We have to generate the idea. First of all, there is square present and there is sin x present. Okay, cos a square is there, sin x is there. At least either the whole question should be in cos or whole question should be in sin. At least something can be done then. I can convert this using 1 minus sine square x. At least then it will be converted into sine. So I'll rewrite this as 2 into 1 minus sine square x plus 3 sine x equal to 0. At least now the whole question is in terms of sine. So this becomes 2 minus 2 sine square x plus 3 sine x equal to 0. I can rewrite this as multiply the whole equation with negative. So 2 sine square x plus 3 sine x, sorry, not plus, minus 3 sine x minus 2 equal to 0. If you look at very carefully, you'll see this is nothing but a quadratic equation in sine. For the time being, if you imagine sine x as some y, you'll see this is nothing but a quadratic equation. Power 2, power 1, then nothing. No power of sine x. So I can do middle term splitting here. So do the middle term splitting. So 2 sine square x 4 na. So minus 4x, sorry, 4 sine x minus 4 sine x plus sine x minus 2 equal to 0. If I take 2 sine x common, I'll get sine x minus 2. Here nothing is common, so 1 bracket sine x minus 2 equal to 0. So middle term splitting helps. 2 sine x plus 1 and sine x minus 2 equal to 0. So pretty much once I have converted the whole question in terms of sine, it becomes nothing but a quadratic equation. Now in order to solve this, we solve the each part separately. So 2 sine x plus 1 equal to 0. So I'll get sine x is equal to minus 1 by 2. Now first of all find theta for it. Now I'll not discuss it again because we have already solved it. Sine x is equal to this minus 1 by 2. So theta is in third quadrant. So that is pi plus pi by 6. So 7 pi by 6 basically. I need 1 theta. We can find both 1, but at least I need 1. So now I can write sine x is equal to sine 7 pi by 6. That gives me x is equal to, just use the format, n pi plus minus 1 raised to power n into theta. Theta is 7 pi by 6 and mention that n belongs to z. This is half of the solution. But about the other half? We have solved only this, na? 2 sine x plus 1 equal to 0. What about this? Let's solve it. Sine x minus 2 equal to 0. You'll get sine x equal to 2. Now if you remember that even if we do rotation, go in second quadrant, third quadrant, basically everything is just the same values with positive and negative. Means in your table of sine, you start from 0, then 1 by 2, then 1 by root 2, then root 3 by 2, and last is 1. And then you still, even if you go in second quadrant, third quadrant, same values are being repeated with positive and negative. Means you can never go beyond 1. That means sine x equal to 2. This is not possible. That means for this there is no solution. So only one solution, that is this one. Sin x is never more than 1. So the moment you see sin x is equal to even 1.001, just say no solution for that. Okay. All right. This one we have repeated same question. Let it be. All right. This is done. Okay. Now let's use some identities also. Not always you'll get a quadratic equation. So look at this, sine 2x. This time there is double angle present, and here it is cos x. Okay. All right. So for this, I can use the property of sine 2 theta. What is sine 2 theta? Is 2 sine theta cos theta plus cos x equal to 0. Now what is the benefit here? I can see that cos x is common in both the expression. Take cos x common, you'll get 2 sine x plus 1 equal to 0. So that gives you two solutions, through cos x equal to 0 and through 2 sine x plus 1 equal to 0. That gives sine x is equal to minus 1 by 2. Now cos is 0. Cos is 0 for pi by 2. So I know just one solution at least. Theta is pi by 2. But I have to write general way. So cos x is cos pi by 2. So x is 2n pi plus minus pi by 2. This is a general solution. That's it. The format. Same way for this one. Sin x equal to minus 1 by 2. I think we just solved it above. So same thing. X is equal to n pi plus minus 1 raised to power n 7 pi by 6. So I'm not going to discuss that again. Okay, this is the answer and this is also the answer. Okay, one more question was there. Just give me a minute. Let me get the question. Yes. All right. Yes, this one. Last one. Okay. You can see sine 2x, sine 4x, sine 6x. Multiple angles are there. Okay. There's one important concept that I also want to discuss this. Okay. So first of all, you see sine, sine, sine. There are three sine. So we can apply sine c plus sine d. This kind of expression we have already dealt with. And remember, we used to apply it on the first and last so that it generates the term in the middle. 6 plus 2, 8. 8 by 2 is 4. So sine 4x will be there. So I'm applying sine c plus sine d on these two. So that becomes 2 sine. Add them, divide by 2. So 4x. Cos, subtract them, divide by 2. So cos 6 minus 2, 4 by 2, 2x minus sine 4x equal to 0. So sometimes the sine c plus sine d identity can also be used. Sine of double angle we just used in the above question. So this, some key basic steps are required. After that, pretty much everything becomes simple. So you can take now sine 4x common. So you are left with 2 cos 2x minus 1 equal to 0. So basically you get two solutions through sine x equal to 0. Once we have to solve this, and 2 cos 2x minus 1 equal to 0. That gives you cos 2x as 1 by 2. Let's solve for this one. What is the general value? Theta. Sine is 0 when theta is 0. So radian is also 0. So I'll say sine 4x is equal to sine 0. So I'll say, since we are solving for not x this time, 4x. So I'll say 4x is equal to n pi plus minus 1 raised to power n into theta is 0. Anything into 0 is 0. So basically 4x is equal to n pi. Remember that x is not n pi, 4x, since we are solving for 4x. So x is equal to n pi by 4 and n belongs to integer. That is the one parameter that was missing in the above questions, that you were never solving for more than x. This time you are solving for 4x. Same thing can be done here also. First of all, always find theta. Cos theta is 1 by 2 for 60 degree, that is pi by 3. So now general solution 2. So for that, write down cos 2x is equal to cos pi by 3 and use the format that 2x is equal to 2n pi plus minus pi by 3. So x will be half. Take this 2 on the other side. So you'll divide both the terms by half. So 2n pi will become n pi plus minus pi by 3 will become pi by 6 after division with 2. Again, n belongs to z. These are the two answers. Okay. So remember that if you are solving for rather than x, so for general solution you will not write x is equal to, you will write 2x is equal to whatever the format is and then calculate x through that. Okay. And this is theta. This is not the value of x. Remember that. It's a principal solution for cos is 1 by 2 when theta is pi by 3. Okay. Fine. That pretty much covers your whole trigonometry, all the identities. all the variations. I tried to cover it. It's a big topic, so as you go through some new questions, you might get to learn some new tricks also, but I've tried to cover most part of it. Okay, and trigonometric equation, it's a separate idea, so for that I'll just recommend you to just get comfortable to find the principal solution itself, because sometimes the student gets stuck with the negative values. How to solve for sin x equal to minus 1 by 2, cos x equal to minus 1, or tan x equal to minus 1, that kind of solution. Okay, all right, fine. That will be all for today. See you in the next class. Good day everyone. Bye.